All right, good morning, everybody. We are going to go ahead and get started. As per usual, I'm recording the meeting to make sure that those who are not joining us can hear it. Um, there's actually portions of this meeting where I lost the audio, so I had to re-record this uh, the day after this meeting. So hopefully I will have covered most of the things that we talked about in the meeting. Uh, Basically, in today's meeting, you can see the agendas up here. We're gonna talk about just in general some training opportunities. Um, we've discussed this in the last meeting and at coordinators meeting. I have these three up here that the National Home Performance Conference in Philadelphia in April, the Energy Out West Conference in Phoenix in May, and then there's also RMGA Code Update Training, which is in Salt Lake on September 6th, or down in St. George on October 12th. So, and then this is a section I had to re-record. I did ask if there were other opportunities that anybody knew of, and there were no answers. So, if you do know of any new opportunities,
yeah, we're seeing the ASHRAE
I would
Calculator.
encourage you to reach out to me or Wade or Dalton and let us know, and we'll kind of share it with the network. But anyway, and for the national trainings, the Home Performance and the Energy Out West, at the state we are encouraging anybody who is interested in going to go, but you do need to talk with your coordinator. It will be up to your coordinator as to whether or not that's something that would work for your agency, something that would be good for you in your learning and your development. I shared with the coordinators at coordinator meeting that I've been to both the National Home Performance Conference and Energy Out West. I feel like they are both very solid conferences. They have a really good offering from a lot of national trainers. It will enhance your knowledge, and anybody who goes will have a good experience there. And if you have to pick between the two, I recommend the Energy Out West in Phoenix, not because it's a better conference, just simply because I felt that Utah should start to support that conference a little more. I felt like most of the rest of the surrounding states have been supporting that conference, and I'd love it if we had a little bit more of a presence. But anyway, so if you're interested, talk to your coordinator, see if it's something that would work well for you or not. And you may have so many other trainings and opportunities this year that this is just not, not the year to do this. But anyway, so that's training opportunities. The next item is that there was some old business. Somebody had a question about, do we adjust ASHRAE for a deficit if we're replacing an old bath fan? And when I go through the new ASHRAE calculator, I will answer that question. So I'm going to skip down to the new business. The new business, the first thing is we have a monthly production report. And we've talked here at the state about some of the things that we can do just to help keep you guys more in the loop of what's going on and what we're doing. One of the things we'd like to make sure everybody's aware of on a monthly basis, kind of keep this at the forefront of our efforts and our thoughts, is where we're at with the monthly production for weatherization. For the last 2 years, we have not met our production goals, and DOE has been understanding about that because of some of the challenges that everybody across the whole nation have faced, particularly with our BPI certified people. But in the future, they will not be as understanding. They feel like we should have gotten over that hump, and we should be able to accomplish what we should have gotten over that hump, and they feel like we should be able to produce the units that we have committed to. So this chart represents the weatherization, just weatherization, not crisis, but what represents the weatherization completions that each agency has committed to. You'll see that the red is the goal, and the blue is the actual completions. So in the month of July, for all 7 agencies combined, we had a goal to produce 32 units, and we only produced 19. Now this is a running total, so in August we added the goal for August plus the goal for July, and the combined total is now 74, and at the end of August we had completions of 41. Now the goal, just wanted to be clear on what that is. So Brad asked each coordinator to set a production goal, and he asked them to factor in crisis. So your coordinators may have thought, well, in August we won't have that many crisis calls, so we're going to produce 10 units. But then in December we'll be inundated with crisis calls, so we might only produce 2 units. So the crisis and some of the other things that your agency do throughout the year, those should have been factored into this. It wasn't just us dividing the total number of units by 12. So when we have a month where we don't reach the goal, we do need to be concerned about it, because not only is this a representation of the number of units that we really should have completed, but this is a slightly lower number than we will have to produce next year. This year, DOE has allowed us to kind of put a little extra money into our training, our TNTA budget, and that in turn reduced the total number of completions that would be due, and that strategically was one of the main reasons why that was done. So next year we'll actually have to produce a few more units than we do this year. So anyway, want you guys to be aware of it. If you don't know where your agency is at, obviously this is the goal for the whole program, but if you don't know where your agency sits, you don't know if your agency met its production goals or not, talk to your coordinators, talk to your supervisors, have these discussions, because we want you guys to talk about them. We want each of you to just be thinking about, what can I do to help the agency and the program to reach these goals. So anyway, that's the production. We will share this information with you each month. So hopefully this is good information. As we get into this, if you have other questions, I'm sure you'll ask in the coming months. So, all right, the next thing on the agenda is the new ASHRAE calculator. I did ask if people had questions or comments about the ASHRAE calculator, and it was pretty silent. This calculator basically, if you have used the calculator recently, you may have noticed the one that we have, when you download it, it actually has a file name that says ASHRAE 622-2013. As of about a year ago, we have been required to use the ASHRAE, or to comply with the ASHRAE 622-2016 standard. But we haven't been in a big hurry to change out the calculator, because the math and the standard in general really did not change. So if you've been using the calculator that we currently have on our website, 99.9% of the time that calculator works just fine. So we just haven't been that worried about it. But we have received a lot of comments over the years about improvements we could make to the calculator. And so we finally took a few minutes. We took some time, and we made some updates to the calculator. I put this out as a draft so that you guys could look at it and use it, and tell me if you have any questions or troubles with it. So Anyway, if you haven't seen the calculator, I'm going to go through an example of using the calculator right now, and then at the end of this, I asked if there were any questions. Again, it was pretty silent. So for those of you who are watching this later, just encourage you, if you have questions, email me. Let me know, what kind of issues you might have. But you'll notice that the title says ASHRAE 62.2.16 ventilation worksheet, and it says for single-family detached dwellings. Now that's important. This calculator only works for single-family detached dwellings. If you have the ASHRAE standard also applies to like row houses, horizontally attached multifamily. So if you have any of that, you have to use the RED, or the Residential Energy Dynamics calculator, and on that calculator you'll have the option to select that they're horizontally attached, and you can calculate ASHRAE accordingly. If you have any issues or questions on that, you're welcome to reach out to me when you run into them. So anyway, let's go through an example real quick to show you how this thing works. So obviously here I'm going to type in the client's name, and the tab order should work pretty good here. This is not completely dynamic, where it's these fields that you see appear and disappear. They don't really disappear. They're just hidden. This is just an Excel spreadsheet. I've tried to write this using basically not using any code, just using simple Excel functions, so that you should be able to run this with most versions of Excel. It should work fairly well, I hope. Anyway, you put in the number of bedrooms, you put in the number of occupants, you can see that the calculator will select the appropriate one, whether it's a bedroom or an occupant. And then you put in the square footage of finished space. There is a definition of what that should be if you hover over the corner, and it will calculate your whole building ventilation needed as you do that. Obviously, you just tab through and fill out all of the yellow fields. On the local exhaust deficit, you've got to identify the number of bathrooms that are in the house, and when you do that, then the appropriate number of rows will appear. There's a little bit of information here about installing an ASHRAE fan in the kitchen. And then also the next field down will tell us the answer to the question we had earlier, which was if I'm replacing an existing fan with an ASHRAE fan, which do I enter here? And the answer is that you always use the fan that will be in place when the job is complete. I'll have to make a minor edit to the sheet so that you can see the last couple of words on that. But basically, if you know you're going to replace the bathroom fan in bathroom number 1, then you're going to tell this when you're estimating ASHRAE that what you're going to actually put in. So in this example, we'll say we're going to put in a fan that'll be 50 CFM, and then there's a difference between intermittent and continuous on the deficit. On the intermittent, basically it only gives you a credit of 30, I think, and on the continuous it'll give you a credit of 50. So if it's continuous or whatever, or actually not a credit, but you're only required to have 20 continuous. So if you are using your ASHRAE fan, make sure you switch that to continuous. But once you put in all the information there, it'll calculate out your total deficit ventilation, and then show you what 25% of that is, and add that to our total ventilation needed. On the infiltration credit down here, we just pick the weather station closest to the job. There's a definition of the dwelling height. It's the vertical distance between the lowest and highest above grade points, but it's there, so if you forget, you just hover over that. Go ahead and put in the dwelling height, and then I've set this up to where you can either put the pre-blower door number in if you're estimating, or you can put the final blower door number in. If you put the final blower door number in, then you'll notice that it finishes the calculation, tells us our total infiltration credit, but also it changes the title. It says it's C06 final ASHRAE ventilation calculation. And then if you were instead to have put in the pre-blower door number, then it makes the final blower door number field disappear. And it changes the title up top just to let you know that it's an estimate. And also, if it's below 4,000, then it will automatically estimate your give you an estimated reduction of whatever that is. That was 1750. If it is 4,000 or greater, then it will do the 50% reduction. And so it's basing the ASHRAE estimate off of that estimated reduction of 2,000. Now, Jesse from Bragg pointed out that from time to time you may have a job where you know you're not going to reach the goal of 30% or 50% reduction, and you may need to modify that. And so we've just set this up to where you can pick a different number, and if you do, then it just gives you a field to explain why, so you can document exactly what you're thinking on your ASHRAE. So that's it, and then at the bottom it gives you a total, tells you how much your total ventilation would be required if you exceed the 15 CFM, or if it drops below 15 CFM, it'll tell you you don't need any. So that's the calculator. Please use it. In fact, in the meeting I asked if anybody had any objection if we swapped out the old calculator with this new one, and everybody seemed on board with that. So that's what we're going to do. So going forward, please start using this. If you have any issues with it, let me know, and we will try to address them accordingly. Okay, now we're going to actually go out into the lab, and we're going to talk about our positive pressure ASHRAE strategies. So these are basically some makeup air connected to a forced air furnace. This is something we've been talking about a bit lately. We've been trying to encourage agencies to try it out. Anytime you run into a home with vermiculite in the attic, if you can't complete a vapor barrier in a crawl space, then you have to use either neutral or positive pressure. We have a couple of agencies that have really started to dial this in, and they've got some really solid strategies. They've got some good experience on how to do this. We've worked with some of them, and we decided we better set up some of these in the lab so that others who are still wondering how to do this can have something to look at. So we built a couple of training modules and built one of these into the training house. We're going to go out here and spend some time with Wade and Dalton, and they're going to walk us through, show us what those look like, and hopefully answer any questions you guys might have about this.
What we've been doing, what we're gonna.
All right, so what we've been doing out here in the house, go through the house and some stuff out here. We've been playing around with some different ASHRAE strategies. In particular, what we've been looking at is some stuff that will provide positive pressure ASHRAE. We all know the drawbacks to exhaust ventilation. We cause appliances backdraft and things like that. Another drawback to exhaust ventilation is for every CFM of air we're exhausting out of the house, we're pulling in a CFM from somewhere. We don't always know where we're pulling that from. That air we're pulling in might be coming from the attic, it might be coming from the crawl space. It's coming from all the millions of holes or thousands of holes left in the house. So everything we're going to show you, there are pros and cons to all of them. And what we want you guys to consider is these are just other tools in your toolbox. And we'll talk about pros and cons of all of them. So the first thing I want to start with is over here on this prop. We've installed this system from April Air. Right? So if we can get Dalton to get in on this. This system comes with a damper. Okay. This damper, you can adjust it to how far you want it to open. So right now, if I set this knob right there, the damper is going to open to its 100% open position. If I don't want the damper to open that far because maybe I want to throttle the airflow back, I can move the damper there. And now when this thing opens, it'll only go to 50% of its position and anywhere in between. Okay, so there's some adjustment there. It comes with a controller right here that you can set up and tell it how many minutes per hour you want this thing to ventilate. It tells me when my ventilation is active. Okay. It will go ahead and turn the system on, so it's going to turn the blower on the furnace and run ASHRAE. Up here you can see now that I've got it running, my blade's going to open to the full open position. And because this is pulling air in on the return, basically I ran a pipe to the outside, it's pulling air into the return, it will tend to pressurize the house because now I'm bringing extra air into the home. So we don't have the problems with backdrafting and the problems with negative or exhaust ventilation. Also, the other benefit to this, guys, is now I know where all of my air is coming from. All of my air is coming from the outside, hopefully from a clean source. I wouldn't want to put this anywhere near like a gas meter that has a vent on it that might vent gas, or near a sewer pipe, or I don't know, whatever you can imagine. But now I know all my air for ASHRAE is coming from the outside from a clean source. Again, remember on exhaust ventilation, yeah, we're exhausting air out, but we have no idea where the air coming back in is coming from. It could be coming from bad places, okay? So if we go over here to the table, we've laid out the wiring for this. Now the thing that's cool about this too is you don't need to hire an electrician, okay? All of this wiring is done right at the furnace. So the kit comes with the transformer, it comes with the damper, and it comes with this controller that you can set up to tell it, here's what I want you to do for ASHRAE, and it wires right into your existing heating system, okay? No electrician required. I know that's been a big problem with ASHRAE is we got to get an electrician. Getting an electrician out there, I know in some cases the cost of the electrician. Now you'll notice there's a few wires on this. It comes with a schematic. The schematic is pretty easy to follow. Anyone who's got reasonably basic knowledge of HVAC controls can wire this in. If you can just follow the schematic, you'll be okay. But this is one option. If this is something you guys want to start doing and you have troubles with the wiring or you need some classes on the basic wiring, just let me know. We'll bring you up here. We'll teach you how to do it. I'll come in the field with you. We'll teach you how to do it. But anyone who's into control wiring, you'll know that this is actually pretty easy stuff, okay? If you're not into control wiring, you might look at all these wires and go, wow, that's a lot to deal with. So there is another option. Come over here to this guy. This is a thermostat. It's the Lyric thermostat. And you need to make sure you get the right one. There's several different ones. The one that works for this is the TH6320. If you get like the TH6280, it won't work. So you got to make sure you get the right one. The beauty of this, guys, is there's one wire. So I got one wire that comes from the common on the circuit board to the damper, and then it goes back to the thermostat. I'm going to pop this thermostat open and show you what we got going on in there.
You want the other one instead.
Let me get a screwdriver. Hold on, let me get a screwdriver. See how easy that was to pop open? But you'll notice inside there's a terminal in here called U, okay? So my one wire goes from the U terminal out to my damper, from my damper back to common on my furnace circuit board. That's all that's involved in the wiring on this. Now there is some setup you have to do in here on this thermostat, so we'll walk through that really quick. Just a quick note on this damper. It has an adjustable blade too, so I can use this screw to adjust how far the blade opens, okay? So if I don't want the thing full open, or if I only want it half open or quarter open, I can use this screw to set that adjustment. But again, guys, here, no electrician required. One single wire to wire with it. But what you do got to remember is we've got some setup to do here in the thermostat, okay? So if Dalton can zoom in on this. And by the way, everything I'm going through here is all in the instructions. So if you just read and follow the instructions, it's pretty easy. But I have an option where I go into the menu, so I'm going to hold the menu button for 5 seconds. It's going to allow me to go into device setup. I'm going to select device setup, and you'll see at the top we have numbers. The ASHRAE setup is clear in the 1000s. So I'm just going to cruise through all these other numbers. And again, the instructions lay this out for you. But notice when I get into the 1000 setting, I've now got some options for ASHRAE. So I'm going to edit this, and it gives me an option. Am I using an air damper? Am I using nothing for ASHRAE? Am I using an ERV or an HRV? Or am I using passive? For this particular setup, if you want this thermostat to control that damper and open and close it, you need to tell it I'm using an air damper. Okay? We can talk about all the other settings at another time. We can do some training on this, or you can read the instructions that come with it. They're pretty explanatory. So I tell it I have an air damper. I'm done. Okay? Which ASHRAE standard would I like to use? I have the choice of 2013. I can base it on percentage of runtime or ASHRAE 2010. In this case, I'm going to tell it I'm going to use ASHRAE 2013. Okay? Tell it I'm done. It's now going to ask me how many bedrooms are in the house. So I can edit that. So I'm going to tell it 4 bedrooms. Done. It's now going to ask me what is the square footage of the house. So I can edit that. Let's go down to 1,300 square feet. Done. Okay. Now it's going to ask me what is my measured CFM. So this is where you've got to tell it how many CFM did I measure through the damper I set up. So here at the training center, we've been able to get as high as 150 CFM. So let's go there. Okay. I've got 150 CFM available for ASHRAE. Done. Okay. It's going to ask me what is my priorities. There's some things in here. You can set this thing to lock out, so you need to let it know. And again, the instructions are more in depth on this. We're just giving you a quick overview. But my priority can either be the lockout points or ASHRAE. You want it to be ASHRAE. If you set the lockout points, you're going to have times where you are not ventilating. So I tell it my priority is ASHRAE. Done. Now my lockouts, it won't even give me an option to do those. It's going to have an option to remind the client to change their filter and a few other things. Anyway, we're going to go through all this other stuff. Finish setup, select. Okay, this thermostat will now run my ASHRAE for me. And the beauty of it is it takes into account the normal run times of the system. So let's pretend that I'm going to do 150 CFM because I'm going to run the damper full open, and I run my ASHRAE calculator, and it tells me at 150 CFM I need to run the fan 10 minutes out of every hour. Okay? The system takes into account how long the furnace runs. So if the furnace runs, it tells this damper to open. Let's say the furnace ran for 8 minutes of my 10. This guy knows I only need to turn the fan on for 2 more minutes to complete my ASHRAE for that hour. Okay? That's a cool feature because I know one of the number one complaints we hear from you guys, and we hear this from the clients, and we see it ourselves, is when you put in a fan, they just turn it off. So one of the benefits of this is if most of their ASHRAE can be met and they don't even realize it because their furnace and air conditioners are running to take care of it, chances are they're not going to turn it off. Some drawbacks to this, you're going to have clients who are going to hate this thermostat, especially old ones. Okay? Another drawback is if the client only has a furnace with no air conditioning, this thing's going to turn their fan on in the summer. And if you haven't educated them, you know what kind of phone call you're going to get. That new furnace you installed runs in the summer. What the hell's the problem? Okay? So you got to be aware of that. But again, no electricians, super easy wiring. We're going to go in the house next and discuss some other benefits. And then I think towards the end, Turner's got a little cost analysis he's put together because there are some costs associated with this, especially if you're running furnace fans. Okay? So, and we all know that, the difference between ECM and PSC. So let's walk into the house and show you what we've done in the house and then go from there. Is there anything else out here you wanted to talk about?
I was going to mention one thing.
we noticed when you are measuring the flow out here, if you use the exhaust flow meter, if you turn the box upside down, you'll get a completely different reading than if you turn the box this way. It's basically just spin the box around a few times, play with it in the field, and you're going to use the highest number you can get. It's typically going to be, if it's one of these downdrafts, it's typically going to be this. I think it was this. I can't even remember now. So flip it around. Yeah,
It was like that.
Don's confirming that. And it's because the air has to flow down and up, and it crosses the where we're reading the pressure. But anyway, so if you're getting weird readings, just spin your box around, take a reading from all different directions, and it's always going to be the highest reading. That's the amount of CFM it's reading. So that was the only thing.
This is just one style of termination that you could use. There are potentially other ones. I like this one because it gives us some protection from the weather, and it's got a screen in it for bugs. Here's another potential option. If you did this, I'd recommend you put a screen behind it because, you know, stuff's going to go make nests and live in there. Okay? I really don't care what you use for a termination as long as it makes sense and doesn't allow a bunch of crap to get in the house. So, you know, experiment with that.
Don't use too small a screen.
Yeah, don't use too small a screen. Let's walk in the house and we'll show you guys some other cool stuff that or at least that we think is cool.
Did you need AC on?
No. Here's another type of termination, guys. That's actually our combustion air for this house. So another potential termination. There's a lot of them out there. So one of the other benefits, or we think that's a benefit of this type of system, is most houses we go in, they have a combustion air opening to the outside. And we've seen that you guys go to a lot of great efforts and extent to close that. And then you've installed an exhaust fan for your ASHRAE ventilation. What we've done is taken our combustion air that went to the outside, and that's where we ran our pipe for this ASHRAE. So you can see we hooked into our combustion air. Now, ours is a little confusing and convoluted because we've done a lot of different things, so we can do different training on it. But at the end of the day, what it boils down to was we ran our 6-inch pipe into our combustion air opening that was already there and ran that pipe over to our return. And now we have the options of setting up whichever type of those dampers, and there's even more ways to do it, but we're showing you a few. But now we've turned our combustion air into our ASHRAE. So rather than trying to plug that all off, hire an electrician and install a fan, an exhaust fan somewhere in the house, we've utilized an existing component, combustion air, and made it into our ASHRAE. Another thing we wanted to show you is, so they recommend that you insulate this stuff, okay? Because if you're bringing in very cold air from the outside and there's warm, moist air in here, which is the case in winter, that warm, moist air could hit that cold pipe and we could get condensation. So me and Dalton insulated this 6-inch pipe by simply sliding some 7-inch insulation right over the top of it. Dalton, how hard was it to put this on here?
That was way easy.
It was super easy and it's super inexpensive. Now I've seen guys in the field who have been doing this insulate this whole pipe with 2-part foam. That's fine if that's your approach, but that's a lot of money, as long as, you know, whatever. But this is just another tool in your toolbox, guys. A super easy way. Just take flex that's one size bigger than your pipe, and we slid it right on over all these elbows, secured it at the ends, and so now we've got a nice insulated intake. We don't have to worry about, in the winter when there's 0-degree air in here, condensation forming on these pipes. So again, just another option, another tool in your toolbox to consider for ASHRAE. And again, the benefit of this, it's positive pressure, so we're not depressurizing the house. And again, I know where all my air for ASHRAE is coming from. It's coming from the outside. It's not coming from the attic. It's not coming from the crawl space or what have you, okay? Do you have anything else to add in here, Turner?
Where do we put this? What's the goal?
The goal, guys, is to get this connection as close to this fan as you possibly can, okay? So we did some testing on this one. We got this one pretty close to the fan. We're 4 feet away. And we got this one back here over 10 feet away from the fan. There was a dramatic difference in our CFM when we started measuring. So if I remember right, you'll have to forgive me, we've done a lot of testing on this. I got a lot of numbers in my head. We were able to get about 70, 75 CFM out of this one. But this one over here, even with the fan on its highest speed, I think the highest we got on this was probably 40, wasn't it, Dalton? So there's a difference if you spread them out. However, I just wanted to point out to you guys, we are very far away from the fan on the furnace, and we still were able to get 40 CFM. So, you know, still an option to consider. But at the end of the day, the goal is get this guy as close to the fan as possible. Crank your damper full open so that you're getting maximum CFM, because now you can shorten your ASHRAE run times. So if we can shorten our ASHRAE run times to the point that the system running its regular cycles could possibly satisfy the client's ASHRAE need, I bet you'll never hear another client bitching about that fan running continuously or they're just turning it off or whatever. Now that won't happen in every case. There's going to be some instances where the ASHRAE controller is going to run the fan when it's not running a normal heating and cooling cycle, and that's where client education comes into play, guys. But if it's running that ASHRAE cycle, and let's say it's only a couple of minutes an hour, the chances probably are that most of our clients won't even realize it. Okay? But again, this is just another tool in your toolbox, and none of this stuff was super expensive. Our dampers were a couple $100. How much was that Lyric thermostat?
If you get the right one,
yeah, and we went over that.
It's about $135, $135, $140. If it's a lot cheaper than that, you're probably buying the wrong one. So
you know, weigh the costs. I know some of you guys hiring electricians to put in exhaust fans. That's expensive. Exhaust fans I know are hard to install in a lot of cases. You will have houses where this simply won't work because maybe you can't get a pipe to the outside or whatever the case may be. But again, this is just another option, another tool in your toolbox. And in my opinion, and this is just my opinion, this is the best approach to ASHRAE. Okay? That's just my opinion. This is what I do in my house.
Wade, another thing is also you can do this in 8-inch pipe or 10-inch pipe if you need a higher volume of air to get lower run times.
Yeah, there's bigger dampers available. So if you want to put in a 10-inch and really move some air, you know, 200 CFM, and get your run times way down to a couple of minutes an hour, by all means, go for it. Now, there has been some questions. One question that was posed to me, well, Wade, you're bringing in all this cold air to the furnace. Won't that crack the heat exchanger? Absolutely not. That's a wives' tale. Okay? There's not enough cold air coming in there to crack the heat exchanger. And also think about it, guys. My heat exchanger right now is sitting here at room temperature, which is roughly 70 degrees. When I fire it up, the flame front on my burners is around 2,800 degrees. If that delta T doesn't crack the heat exchangers, a little bit of cold air from the outside sure as hell isn't going to crack it. Okay? Don't worry about that. Could a 10-inch pipe, if you ran a 10-inch pipe here to the furnace and you were pulling 0-degree air in on a cold winter day, affect my temperature rise? Yes, it could. But at the end of the day, we don't have that many 0-degree days. And if it was really a problem, get with me. There are adjustments you can make here to change your temperature rise. All your furnace guys know that. Okay, so the wives' tale of cold air will crack my heat exchanger is just like wives' tale. It won't crack your heat exchanger. And a 6 or 8-inch pipe pulling in air for ASHRAE a few minutes an hour is not going to have a detrimental impact on your temperature rises. I promise you that. If you run into one where it does, call me.
what about using a pressure switch and having the damper open all the time?
Yeah, so we've seen a situation where they're using they call it a cell switch or a pressure switch to cause the damper to always open whenever this runs. So it has nothing to tell it, only open the damper for so many minutes. Just whenever this system ran, the damper would open wide open. That's probably going to way over ventilate, guys.
It's going to cost the client a fortune.
And it's going to cost a lot more money. And Turner will kind of go over at the end of this some cost analysis. So it's our opinion right now, the cell switch method probably isn't the best approach. We can evaluate that a little more down the road and see, but the goal behind this is maximum CFM in the shortest amount of time is what it boils down to. And again, remember, this is just another tool in your toolbox. So anyway, anything else?
What questions do they have while we're out here?
Yeah. What questions do you guys have for us while we're standing out here looking at all this? Can you even hear me?
Yeah, can we get you to come down and write the first one in?
What was that?
Wants you to come down and put the first one in.
You get it scheduled, and I'll see if I can find time in my schedule to come down and help you. How's that?
Okay, sounds good.
Hey, did you use a pitot tube to get the pressure measurement, the CFM?
No, you actually use the fan flow. So let's step back outside and we'll show you how we did it.
You want to have a manometer on there?
We'll just show them. So if I understand you correctly, your question was how did we measure the CFM through any of these? Is that right?
No, just asking if you've used the pitot tube or just the flow meter there, and how accurate. I mean, are they both pretty consistent?
I haven't compared this to using a pitot tube. So we've done measurements with this. This is as accurate as anything I've ever seen. The only drawback to this is it does have limitations of about 150 CFM. So when you say use a pitot tube, are you talking about using a pitot tube to transverse the ductwork and then get an average reading and convert that to CFM? I just want to make sure we're on the same page here.
Yes.
Okay. No, we have not used the pitot tube to transverse the ductwork to get a CFM reading that way. We could certainly try it and see if it's any more accurate than this. I doubt it will be, and this is just a heck of a lot easier. Okay.
I'm glad he brings it up, though. This is an issue we're going to run into, because as soon as you go to an 8-inch duct or a 10-inch duct and you really start moving some air into the house, this won't work.
That's right.
Because it, as you just mentioned, it has a limit of about 100.
Yeah, this has a limit of about 150 CFM. So if you're getting into bigger CFMs, then we're going to have to look at other ways of measuring airflow. So using a pitot tube to transverse the ductwork and do some math is one way to do it. It's a complicated, time-consuming way, but it is one way to do it. There's also, I don't have one right here with me. I've got part of it. So there's this filled piece meter. You can get an attachment that goes on it called an anemometer or a velocimeter, and you can use it to measure airflow, but there's some math that goes with it, so you have to be able to do some math, which we can show you what that math is. And these are not nearly as accurate as this, but it'll get you reasonably close if you're talking large CFMs over 150. The only other way to get very accurate measurements is with a flow hood, which are thousands of dollars, and don't work very well on systems like this. The flow hoods are usually only used to measure supply airflow. So again, our recommendation is just, let's start using this. If it's something you guys are doing, all you do is cover it with this, just like you would any other exhaust, because it's sucking air in here. And like Turner said, depending on your hood style, you may have to flip this around to get the right reading, but whatever the highest reading turns out to be is your correct one. If anyone out there wants to go ahead and get a pitot tube and transverse the ductwork and do the math and get that measurement and compare them, I'd love to see your data. I may try it myself now just because someone asked and see what the comparison is. But no, we haven't tried it yet.
There is a calculator on RedCalc as well,
I
think, for the pitot tube.
Red Calc's got some good stuff to that.
That might be a nice cheap solution.
Yeah, that might be the solution. I'll have to look at it. If your CFMs are way higher than what that'll measure, that might be a solution. Another thing we noted that was kind of cool, the addition of this pipe into the return caused our static pressure to go down. So we often see systems in weatherization where we have high static pressure. And so the addition of this extra hole, if you will, into our return caused our return static to drop. In the case of this crop, by 1 full inch of water column. Now, granted, this is a very short tube, but there are some instances in homes where you may have a very short run. Inside the house, our drop in static pressure on the return side was roughly 1/2 to 3/4 of an inch water column. But again, just something else to consider. It helped with static pressure a little bit. So if you have a static pressure problem, and this might help. So, any other questions?
There was a comment about using a pressure switch, and the reason for using the pressure switch was because there was not an extra wire up to the thermostat.
Right.
And I just wanted to address that. We understand that if you're going to wire either a thermostat or if you're going to wire the April air system in, you do have to have that extra wire to the thermostat. On the April air system, the extra wire is represented here. Sometimes if there are enough wires coming from your thermostat, you have the extra wire, you can make that connection in the furnace. But if not, you do have to run one extra wire up to that thermostat. I think, and it's open for discussion, I think as a best practice, we should try to figure out how to run the extra wire. And I'll go over some numbers in a minute, but if we start over-ventilating our clients' homes, it is going to cost them a lot of money. And so at least right now, my opinion is I would rather see us run the extra wire and go to the effort of doing that, or look at installing an exhaust fan and having an electrician come and fish a new wire in the bathroom. But I'm kind of looking at fishing a new wire here and fishing a new wire in the bathroom as sixes in most cases. But I'm open to discussion, obviously.
Generally, if you're doing a new furnace in the house, most of the time your guys are going to be pulling a new thermostat wire anyway, or a lot of the time. So, you got to be cognizant of what you're doing. If this is going to be your strategy, your HVAC guys are going to be there, you need some extra wire, let them know, hey, instead of pulling a 4-wire on this job, let's pull a 6-wire or an 8-wire so we have the extra wire available, because our ASHRAE strategy is going to be one of these setups. So you just got to kind of think it through as you're going along. It'll come with time as any of you start playing with them. We'll start to figure this stuff out as we go through. There's always a learning curve. So, but again, these are just other options, or if you will, other tools in your toolbox to help you achieve what we need to achieve. And we have to implement ASHRAE. So here are some other options to help you. And again, in my opinion, better options than exhaust ventilation. So there you go.
Oh, so Wade showed on the lyric how to select ASHRAE 2013. If you'll select 2013, it does meet the 2016 standard, and that's part of the reason why Honeywell hasn't updated it. But it does not give you an infiltration credit, and it does not give you your credit for or it does not increase for your deficit, for your spot ventilation. So I think what we need to do if you're using this is you actually need to do the math, and then you need to, instead of selecting the 2013 ASHRAE, you just need to select the percentage of runtime, which is another option in here. If I was doing this in my home, I'd set this ASHRAE, and then I would also use the lockouts for the high temp stuff. But again, and same thing over here on the April Air. We showed the April Air comes with an outdoor thermostat, or temperature sensor. When we're setting this up in our clients' homes, you cannot use that, because if you do, then the April air uses the high temperature and locks it out, and basically this now no longer meets the ASHRAE standard. Since our program requires that we meet the ASHRAE standard, we can't install that in our clients' homes. If I put this in my own home, I would absolutely put it in. I think it's a great feature. Anyway,
anything else, guys, that you want to go over while we're out here? If not, we'll go back into the classroom and get on the computer and kind of wrap things up, and Turner will go over kind of a cost analysis for you on what some of this stuff might cost a client to run.
All right. Now, for the last part of the meeting, we just did a little bit of testing on some of these strategies, and I wanted to share with you guys some of the things we found. There's not a perfect ASHRAE strategy, as you'll see from the results of this. So here on the right, I've got a couple of pictures of a PSC motor and an ECM motor, or a high efficiency multi-stage motor. And what we did is we set the static pressure of these furnaces in the lab at right at 0.5 inches of water column, and then right at 0.7 inches of water column. And we ran just the fan only, so just the squirrel cage was moving. And we plugged in the kilowatt meter so that we could see how much it would cost to just run the fan on both of these furnaces. So if we're doing this makeup air and we're using that to ventilate our houses, I just wanted to see what it was going to cost your clients. Now over here on the far right, we have the PSC motor. So this is the standard motor you'd find in older furnaces, and then on the left we have the high efficiency multi-stage. For the PSC motor, and we clocked them for 1 hour. But for the PSC motor at 0.5 inches of water column, it is going to cost your clients, if the kilowatts cost 11.5 cents per kilowatt, it would end up costing your client $184 a year to run that fan continuously. Just turn it on 24/7 and leave it on. And then if the static pressure goes up, it would actually only cost your client $162, and that's because in a PSC motor, the motors get lazy, and basically they don't ramp up to push more air through the system. So you actually get less ventilation and less air through your system when the static pressure goes up, but it also uses less amp draw because the motor doesn't work quite as hard. Now over on the left hand side, we have the high efficiency motor, and this one, as expected, at 0.5 inches of water column, it's going to cost, if you ran that thing non-stop, it would cost $127 a year, and at 0.7 it would cost $169 a year. So obviously the cost is higher when the static pressure goes up here, because the ECM motor senses the higher static, but you've told it you need 80 CFM of air moving, and so it will ramp up its speed and give you exactly what you ask for, or whatever the furnace is set for. It will ramp up its speed and give you that. So you've got to be really, really careful when you're selecting this as an option, because if you have a furnace or a duct system with high static, you could end up costing the client a lot of money if you're ventilating. Now with this, the strategy needs to be that you don't want that fan running all the time. You don't want to be ventilating 24/7, because it's going to cost the client a lot of money. So the idea would be that you would actually use a larger duct. So you can start with a 6-inch duct, but if you know you're going to need a lot of continuous ventilation, if you could step up to an 8-inch duct or a 10-inch duct on this makeup air, then you could, instead of doing a whole bunch of air continuously, you could cut down to where you're doing lots and lots of air for a shorter period of time, or basically now the fan only has to run 50% of the time. And no matter how big the vent is, the cost on that fan is not going to change. It's basically just going to be based on your static pressure when you're done. Also, one of the, just kind of the bonus features of putting in the makeup air is that your static pressure on your whole system will actually drop. When that vent is open, your static pressure will go down. We found with a 6-inch duct on the furnaces in the lab, our static pressure, so we had a very small duct system, but we dropped 1 inch of water column in the lab. On the training house, where we have a little more realistically sized duct system, we dropped about 1/2 inch of water column on the duct when we added the makeup air. So adding the makeup air will actually drop your static pressure, which means that your motor, at least your ECM motors, will cost less to run, but still you don't want to cost your client $127 a year to run this motor if you could cut that time in half. Okay, so I'm just going to hide some of this stuff. I kind of did a pros and cons, which I may publish this whole thing at some point, just to help auditors make decisions about which ASHRAE strategy they want to do on a home. But just for a quick comparison, when we're talking about dollars and cents here, so our Panasonic Whisper Green fans, they cost about $135, and their cost to the client, if you turn that thing on and run it nonstop for a full year, it's only going to cost the client $12. Now, our fan at the training house, I tested that one. It has 80 CFM of air movement. If we left it on nonstop for a year, it's only going to cost the client $12. All right, the next strategy is the balanced pressure. It's the ERV, HRV. This one's not a bad option cost-wise. It only costs the client $18 a year to run that thing nonstop. But there are some drawbacks with the ERV that I don't really love. So they tend to be a lower CFM. They don't move as much air. I think that's because of the noise issue with ASHRAE. If you get above 1 zone, then it doesn't comply with ASHRAE. But they have an intake and an exhaust here on the same vent, so you're essentially just looping air around in a small area, so you don't really get good air mixture throughout the whole house. It's really just in whatever room this fan is in. They also have a filter that the client has to maintain, and we know how well our clients do that. But it's not a bad option if you have a home with vermiculite, if you can't complete the vapor barrier in the crawl space, you need to put this house under balanced pressure or positive pressure. But this home does not have a ducted heating system, then this may be your best option. So they run about $350 on up. Now the other two, the positive pressure, the dampers that we've been talking about out here in the lab, the April Air one, which is a damper plus a little controller that you put near the furnace. You just dial up the percentage you need. That's $155. And then the combination of a damper and the Honeywell Lyric thermostat. The thermostat was about $135 and the damper was about $100, so that's about $235. Again, make sure you buy the correct one. It's the T6-320. There are some other versions of the T6 which are a lot cheaper. Those will not work. You'll end up, they won't open the damper for you. But anyway, what I did to estimate the cost on this, you'll see that the cost to the client now is up to $54 a year. I did that based on 50% runtime, and then I subtracted about 7.5% of that 50% runtime when we would get our ASHRAE ventilation for free because there was a call for heat or cooling. Like they were going to heat or cool the house anyway. So basically this $54 just represents the extra time that that fan only had to kick on the furnace. So really about 42% of the time, which based on our tests out there at $127 under good normal conditions, half of that, a little less than half of that is about $54 a year. those are very loose estimates, so they could kind of be all over the map. You'll want to watch that. But again, if you had to run that fan, if you left that damper open all the time, it's going to end up costing the client $127 a year, or basically we're talking about, you know, $10, $12 a month on their power bill just to do their ASHRAE. And our whole goal was to cut their power bill down, so, you know, be very careful about what you're doing. Now this last option over here is completely untested. If any of you have ever tried it or know anything about it, I would love to know more about it. But what it is it's also a positive pressure system. You put it just like we've done but with the other two dampers. You put this into you basically duct outside, run your duct through this, and then you run your duct over as close as possible to the air handler. And this has a mechanical damper in it, and then it also has a fan in it, and that fan uses way less power than the motor on your furnace. So this system, and then it uses the same controller as the Aprilaire damper and controller. So you set the dial on the front of it to the amount of ventilation you need, and it keeps track of the amount of ventilation that you get from your heating and cooling, and then it will kick on the little fan inside of this box to make up the rest of the ventilation. The fan inside of that box, it says that it will push up to 200, or actually a little over 200 CFM, and that's just through a 6-inch duct. And it does have a filter in it. I need to figure out if we can run this thing without the filter, because it would be nice to know we could just pull the filter out and just use the furnace filter. But I'm not sure where the filter sits in the system or how important it is to, you know, the fan and the maintenance of this system. The filter is washable, but again, we now have a filter we know that our clients will never touch, so this may not be the best option. But for the parts, it's $310. If we were running it 50% of the time, it would end up costing our clients maybe $27 bucks a year, something like that. So anyway, those are some strategies. If you guys have others or other ideas, we're open to them. The goal is the least amount of maintenance for our clients. Now, one other thing to think about is with these strategies, particularly with the first one, with the Panasonic Whisper Green, if you're putting the home under negative pressure, that, I think, a lot of the time in our program is what triggers the need for us to replace the water heater. Because when you're doing your worst case draft test, if your fan puts the CAS into worst case condition, then that fan has to be turned on. Now, the balanced ERV and the positive pressure strategies should usually put the CAS in a more positive condition, and therefore when you're doing your worst case testing, all of these systems would be shut off. But yeah, if you're putting the house under negative pressure, a lot of the times it's causing your natural draft water heater to not vent. And so our go-to solution for that is now to spend another $1,200 on equipment, install a new water heater, and now this new water heater, that your direct vent water heater, has a power vent on the top of it, which you have to plug in, and it starts using electricity. Your clients, before you showed up, they were getting that venting for free. It wasn't costing them anything because they were using gravity. And now you've just plugged a little electric motor in their house, and that's going to start to cost them every month. I have a power vented water heater. It's not a direct vent water heater, but it has the same motor in my home. So I put the kilowatt meter on that just for the weekend, and I found that it costs about $10, $12 a year to run that. So when you're looking at $12 a month or $12 a year to run your Panasonic Whisper Green, if the Panasonic now triggers you to have to install a new water heater, and then your cost now went up about $10 a year, give or take, depending on how the family uses their water heat or their hot water. But so now we're up to $22 a year just because of ASHRAE. So be careful with your strategies and really consider what they're doing to the client's total power bill. And as you guys are out there, if you think of ways to cut these things down, let's talk about them, because our goal is to reduce their total energy consumption. Hopefully this was helpful. We really appreciate those agencies that have already been out there trying to do this. If you guys need more training or more help on any of these things, if you need Dalton or Wade or myself to come and help walk you through any of these things, let us know. We'd be happy to help. Thank you so much. You guys have a great day.
Hey, thanks, man.
Thank you.